Thank you for joining us here for our third coffee talk in a series of webinars put on by the Global Forum for Geography and Statistics and with the support of the United Nations Economic Commission for Europe. My name is Kit McManus. I'm a GIS developer at Columbia University. And, today we're going to be talking about defining urban areas and modeling urban area data. We have a number of speakers. There'll be two separate sections, and I would ask that you put your questions along the way into the chat, but we'll come together for questions if there's time between talks, and then if there's more time at the end of both talks. So it's my pleasure today to introduce some folks that I've been able to work with for the past decade. It's hard to believe that it was in 2011 when there was the first Human Planet Forum hosted at the Joint Research Center in Ispra. And it's amazing also to see in the past 10 years how much things have progressed. And today we're going to talk about how to classify settlements from the high level. We're going to hear from Louis Dijkstra, who's the head of economic analysis sector at the DG Regio of the European Commission. And we're going to hear from Deborah Balk, who's a professor of public affairs at the Marx School of Public and International Affairs at the City University of New York and the interim director of the CUNY Institute for Demographic Research. So they're going to give us an overview of, why our urban definitions are important and why is it important that we have a common definition that we use from country to country. After that, Marcella Sciavina who's a scientific project officer at the Joint Research Center, and Thomas Kemper, who is the GHSL project lead in the Disaster Risk Management Unit at JRC, are going to tell us more about some of the technical aspects of applying these urban definitions to produce GIS data sets. So I don't want to take any time from our speakers. So Louis, whenever you're ready, you can take it away.
Thank you, Kit. Let's see if I still remember how to share. Screen, that is. Okay. Should be able to see my screen now in full screen.
I can see it, Louis.
Amazing. So I'll give you a quick overview of the work that we've been doing. And really it's to tell you a bit more about the degree of urbanization. This was a definition which was endorsed by the UN last year for international statistical comparisons. And here on the left-hand side, you can see the cover of the methodological manual that we published and what was also submitted to the UN StatsCom earlier this month. So one of the big reasons we wanted to start this work, because we started it at the Habitat 3 conference in Quito in 2016, was that we had a number of sustainable development goal indicators that were incredibly sensitive to where you draw your boundary for your rural areas or for your cities. For example, the number of children in school and their proficiency. If you include towns in your definition of rural area, you might get a very different number than if you don't. The same is true for literacy or access to drinking water, or electricity, or coverage by a mobile phone network. And in the manual, we actually show some of these data by degree of urbanization. But also if you look at the city definition, if you only look at the city center and consider that only as part of your city, you're going to have a lot of your population with good access to public transport. But if you include more of that city, the surrounding neighborhoods, or even beyond, you're going to get a much lower number. So again, very important to agree on how to draw that boundary. Same is true for open space or land consumption. So what we did is we created a coalition of 6 international organizations. I work for the European Commission, and it was really the DG I work for, the Joint Research Center, from whom you'll hear later, and Eurostat that worked on this intensively. Then we had the OECD, the World Bank, UN Habitat, FAO, and ILO. And we all wanted to create a global people-based definition of cities, urban, and rural areas. And this is what I'll be presenting here briefly. Maybe before I go there, one of the things I wanted to emphasize here is that we really wanted to focus the settlements as concentrations of population. So the spatial concentration of people in space. That was for us the essence of what is a settlement, and that's also what the UN highlights. And so we didn't want to use any proxies, use buildings or addresses as a proxy. We really wanted to get a count of the residential population. So how does it work? Some of you are already familiar with this, but let me go through it. First, we start with the population grid. And I have to say, working with the grid was really what enabled us to make such rapid progress and get this endorsed at the global level. When I first proposed this project to the UN, they were like, we've tried this twice before. It's impossible to get a city definition endorsed at the global level. So that wasn't very encouraging, but I felt like the population grid, because it gets rid of a lot of the distortions, really makes life a lot easier. So on the left-hand side, you see an example. This is a population grid estimated together with SANSA by the JRC. And so we measure, we identify cells which are part of an urban center and part of an urban cluster and the remaining rural grid cells. And then we use those grid cells to define the types of areas. So you can have a city like Durban, or towns and semi-dense areas that could be like peri-urban or suburban, or smaller towns and rural areas. In a nutshell, we have three types of grid cells. So we have, contiguous grid cells above a density of 1,500 inhabitants per square kilometer, and those contiguous cells have to add up to at least 50,000 inhabitants. That determines your urban center, which will then become your city. The second step, you've got the urban clusters. These have a lower density threshold, 300, and they only need to have at least 5,000 population in those clustered cells. And then you have the rural grid cells. Those are all the remaining grid cells, typically below 300 inhabitants per square kilometers, but also the other cells which don't belong to the two classes above. And so urban is everything which is a city or a town and semi-dense, but I prefer really to use the three categories of the degrees of urbanization as I find it much more informative. Cities have the majority of their population in an urban center. Towns and semi-dense areas have their majority in an urban cluster and are not classified as a city. You can also classify this one as the residual, and your rural areas are the ones which have more than half their population in rural grid cells. Now, why did we opt for this method? I mentioned it already. The population grid is really a substantial advantage. It reduces the bias, often known as the modifiable areal unit problem, MOUP, that you have when you work with spatial units with different sizes and shapes. And here I try to demonstrate that. On the right-hand side, you see a population grid. I circled two little settlements. On the left-hand side, you see the population density of administrative units in the Netherlands, and you can see the settlement in a small municipality quite clearly, but the other municipality disappears. I also mentioned already early, we're looking at the concentration of people in space, and this is very important as people take up more or less building space or in different parts of the world or even different parts of the same country. So using a proxy of building clusters really doesn't work so well. I mean, the same building may have, only one person in it in one country or one city or one rural area where it might have 5 or 10 or 20 people in it in another one. So the amount of built up area is a poor proxy for the total population there, especially when you're working at the global level. And really to make it comparable, we use the identical population and density thresholds across the globe. We also have captured, in a way, the urban-rural continuum. We define cities we define towns, and we even define villages. This is at the second level of the degree of urbanization, where we have 6 classes: cities, towns, suburban areas or peri-urban areas, rural areas, dispersed rural areas, and villages, dispersed rural areas, and mostly uninhabited areas. Also, the SDGs want you to monitor access to services. And this is where we had a lot of discussions with the National Statistical Institutes, because this was really a point of contention. Many countries define urban based on the access to services. So you can only be urban if you have access to drinking water, if you have electricity. But of course, if your definition includes access to a particular service, you can no longer monitor that access to that service through these definitions. So really, this required a change of perspective, and we really thought that this was a very simple and neutral definition that would really allow us to monitor those services in a much more reliable manner. And in the end, it's fairly cost effective. It's not that difficult to create a population grid, and also a number of organizations, including JRC and Eurostat and Habitat, are providing assistance to apply this method to national data. So here's an example of what we calculated of access to safely managed drinking water. And here you can see in blue the cities, and in orange the towns and semi-dense areas, and then in green the rural areas. And typically you see that there's access to this safely managed drinking water is considerably lower in the rural areas. The towns and semi-dense areas typically take on an intermediate value, and cities tend to have the best access within the country. We went further, and here you can see an example of the degree of urbanization level 2. We found data where we had the location of every healthcare facility in sub-Saharan Africa, and so we could calculate the distance to the nearest healthcare facility by degree of urbanization. And as agglomeration economies would suggest, typically the shortest distance is for the cities, where you get the highest concentration of people. Towns do a little bit are a little bit further away. Villages come next, and it's the dispersed rural areas and that are really the furthest from the healthcare facilities. So this method was endorsed, I mentioned already in the beginning, so it was last year, and it's not to replace national definitions, right? This was another area where people felt a little uncomfortable. This is not challenging national definitions. They can be tailor-made to data availability, particular national issues. They may have links to national policies or funding instruments. We don't want to touch that or challenge that. That's absolutely fine. But when you want to compare yourself to another country, it's important to use a definition that the other country can apply as well, which is often not the case for national definitions. So this is really something we consider as a critical complement to the national definitions out there. Here you can find the information I was just mentioning. You can find the new manual, the UN recommendations and endorsements. The JRC, and I expect Marcello to talk a little bit more about that, has developed tools on how to apply this new method. And there is also a joint report we published with the OECD on cities in the world. Now, before passing the floor to Deborah, I wanted to give you one last bit, a takeaway from my side, in the sense that what we really discovered by applying this degree of urbanization is that we all agree that there's an urban-rural continuum, and I think the national definitions all work on that continuum, but where they make the cut between urban and rural differs substantially from one country to another. And certain countries, they really make the cut that only large settlements, 50,000 or even more, are considered urban, and all the rest is considered rural. And then in another country, it's the opposite. It's only really small settlements, 5,000 or less, that are considered rural. And as soon as you hit, 6,000, you're considered urban. And this is not always obvious from the definitions because a lot of countries use designation, so they just select their number of urban areas without having a formal statistical definition. But because we apply the degree of urbanization to the globe, we could compare the numbers. And so what we found is that the degree of urbanization, cities plus towns and semi-dense areas, typically matched up quite well with the definitions used in North America and South America and Europe and Oceania. But then for quite a few countries in Africa and Asia, what they defined as urban was much closer matched to what we called city, and typically didn't include what we call towns and semi-dense areas. And so this different approach to where to split the urban-rural continuum was revealed by virtue of having these global estimates done by the JRC and by virtue of having a harmonized definition. And I think it can really improve the reliability and the comparability of the data that we collect for the Sustainable Development Goals to having these three classes instead of two. And instead of trying to tell people, well, this really is urban and you're wrong, we try to come up with a compromise saying, okay, in the middle of the continuum, there's some bits where people don't agree on. Let's call it something in the middle, moderate density areas or towns and semi-dense areas, as we call it. And everybody agrees that a large city is urban and everybody agrees that rural is rural. So this is how we try to solve this conundrum that different countries had a different view of what is urban and what is rural. And with that, I'll stop and pass the floor to Deborah.
Thank you very much, Lewis. So folks, if you have any questions for Lewis, please add them to the chat and, we'll take some time to address questions a little bit later on. Deborah, are you ready to go? You're muted.
Sorry. Hi. Sorry. Thanks. And thanks for your passing the baton perfectly, Lewis. Thank you. So let me just share my screen. Yep. Okay. Can you see my screen?
I can see it.
Okay. So I'm just I have a bunch of comments. I think we have some people here present from national statistical offices, but also from other agencies. And I just want to highlight that understanding urbanization is really, really essential. I'm sure this is everybody who's here actually agrees about this, but I would just, repeat that most of the future population growth is going to take place in the cities and towns of the global south. We believe that's to be true, despite the fact that I think methods to understand that are, in fact, pretty broad brushstroke methods. But we're certain about that. What we're not certain about is exactly where they're going to grow, how they're going to grow, and that's where products like this, data sets like this, and approaches like this to be employed both in a comparative way and by particular countries are particularly valuable. I would say rigorous comparison across countries and even within, and this allows for within country comparisons as well, which is really interesting. It's critical, and until recently, it really wasn't possible. Recent efforts, such as the degree of urbanization data that Lewis has just showed us, it's super important in establishing concepts and measures for this comparison. And I would also argue that recent efforts are a starting point, not an end point. And I want to come back to that. Like we can continue to improve these products. How? Well, population data remain at the backbone of such efforts. Lewis said people-centric approach many, many times. Of course, he also said that there is a building footprint in these data set as well. And so those ancillary data are also really valuable. But the legitimacy of these data products depend very much so on locally rooted efforts, such as those in National Statistical Office. And those allow for both local and global comparisons. So it's not to supplant the work of that's done in country, but it's to use the best available data so that comparisons can be made across country and again within country as well and in a spatial framework. I would argue that the NSO data are a backbone. The NSO data, the data collected by national statistical agencies, they matter a lot. Population counts are at the finest scale. I can't stress that enough. I'll show you a graph on that in a minute. Kit knows this very well. It particularly matters for, you can break this down. Lewis started off with applications. Many of those applications are intrinsically spatial, even if they get reported up at the national level or the core subnational level. So having a rigorous spatial backbone is really important. having other attributes, and maybe we'll hear next from Marcello on some attributes that really matter. So not only do you want like age, sex distributions of population at the finest available data, but ideally you want to know what the country-specific urban delineations are for those spatial units. Those matter because that then helps translate some of these data products and also do validation work. And I'll give one or two examples of that. Satellite and other ancillary data have really been a tremendous input into these data sets. They're super valuable, but the quality and utility of the degree of urbanization type data products depend very much so on the data collected by the national statistical offices. So they depend on both, but and in fact, the motivation for them is partly in places where we have poor population inputs, but in fact, poor population, like spatially coarse population inputs. But in fact, since we see that the quality of these data products improve tremendously by the when we have finer resolution census data, I want to encourage everybody to have, you know, every country should supply those kind of data if they can. It shows that the data products, and I'm going to give an example from one of Lewis's paper as an example of that. The inputs to the degree of urbanization, we'll hear more about it, are basically the gridded population of the world and the global human settlement later that get translated into yet another product. And then through a suite of rules, which I think we'll hear about, which are very transparently applied, are given here. If a country disagreed with these rules, they would be, you know, there could be country-specific applications. But without knowing some of the critical without comparisons with these fine-grained spatial data at a country scale, some of those comparisons can't happen. Just in the upper quadrant here, we see that GHS pop, which is the backbone of the degree of urbanization here, but we also see how it differs from the gridded population of the world. These other two population data sets are Landscan and WorldPop, two other models that are also used. All of these data products would be improved by increasing the spatial resolution of the population data sets that underlie them, that are collected by national statistical agencies. The remote sensing data products, the urban remotes, these are 4 different depictions. And I won't go, I think I'm short on time, so I'll come back to this only if there are questions later about it. Right, so this is transforming those into data products that can be used. This is the graph I was mentioning from Lewis's recent paper, which looks at, it really shows that the spatial resolution of the underlying population data really matter. What we see here is that this scatter plot shows that the population weighted average size, the smaller and finer resolution of the census units, the better the difference between population models are. So the more certain we're going to become about understanding where population is. If we know where population is, then the other rules that we apply to them can be evaluated with much greater transparency, and particularly in urban and clearly urban settings. Now, to Lewis's other point, that what's going on in the middle of these places that are quasi-urban or what we might call semi-dense towns or suburbs, and the language, I think that the terms we use to describe these is open for, is an open question. It's like, what is a suburb in the United States is not a suburb in another country. What is a small town in, in an African country, in Tanzania, for example, might be much different in a European context. So I think we need to be thinking about what goes on in the middle. So this alluvial plot here shows for India an urban and a rural definition. They actually have several things that go into what describes urban, but for simplicity, just all the things that meet that urban definition are shown here. In the middle, we compare only the census data with the GHSL satellite data that are the backbone of the degree of urbanization data. And then this is the degree of urbanization 7-class distribution, which can then be collapsed to 3. And you can see the green areas, the areas that are pretty much called rural by the census, are pretty much identified as rural or sparsely inhabited by the degree of urbanization data set. The areas that are clearly urban are also, there's high agreement there. It's this stuff in the middle where there's a lot of disagreement. And I think that disagreement is where the conversation has to be had. And that conversation will happen because we have these data products. So we need better census data, and we need more attention to doing these kinds of comparisons and having conversations about what they mean in place and comparatively. So this is just when you change the threshold, you apply a different a more restrictive threshold to how much built up area you use. And so my recommendation for this is that censuses must collect and invest and collect and make publicly available the finest resolution census data possible. And for countries that have moved beyond censuses, the same holds for the administrative or other kinds of surveillance metrics that they may put in place to then create census-like aggregates at fine spatial resolution. I would strongly encourage people who might be here from national statistical offices to collect information other than population counts, in particular the country's own urban classification. Those can be really essential in validation and also in predicting future growth. I have, again, more to say on that at some point, but in my own research, we found that it's extremely helpful in both cases, and that will matter for understanding where we can expect future population growth to occur, future urbanization to occur, future populations at risk, for example, of particular disasters, climate hazards, sea level rise, and so forth. And finally, I want to mention that the finer our spatial inputs get, the harder it becomes to make equivalency over time. So it's important to start thinking about equivalency in these very small units that we can track over time. It's intrinsically tricky because that's sort of the nature of urbanization, but it's really desirable because change over time, it's those units that are changing over time often that are subdivided and so forth are the places that's where the dynamism is. That's the places that are transitioning from maybe uninhabited to a town, or from semi-urban or quasi-urban or suburban to more urban and so forth. So, so these, it's really important to be able to capture that. And with that, I will stop I think I'm probably out of time, and I will stop sharing and pass the baton.
Sure. Thanks a lot, Deborah. That's a call for action for all of us to, what can we do to keep on improving this as we move forward. So I appreciate that. We do have some good questions that have come in the chat, but unfortunately, I don't think they can be quickly answered. So I think we need to hold them until the end of our discussion. So we're not changing topics, though. We're going to keep talking about the degree of urbanization, and now we'll hear from Marcella about how technically these methods are applied to produce the GIS data. So Marcello, whenever you're ready, feel free to share your screen.
Okay, thank you, Keith. Good afternoon, good morning, everybody. Okay. So I'm Marcello Schiavina, scientific officer working in the Global Human Settlement Layer team at the European Commission Joint Research Center. And today I'm going to present you a practical application of the degree of urbanization to Colombia country that will be soon published as a public JRC technical report, which covers here shown. In this presentation, I will introduce you the methodology of the degree of urbanization, what is needed to compute it, and what you can get out of it. Briefly show you all the steps from input census data to the classification of territorial units, the two input data for the analysis in Colombia, and then all the results. But let's start from the beginning, why we do such thing and for what, and which analysis can be made. As already exhaustively presented by Luis and Deborah, this approach has a lot of advantages, allowing a statistical comparison at the international level. This means that all the results obtained from this country, Colombia in this case, are then comparable with same results for other countries as based on common definition. All the process is based on a population raster on a regular grid in equal area projection. This means that each pixel both represent counts and density, and produce a classification of territorial units into rural and urban that can be used for several analyses as the disaggregation of age distribution, gender, or access to infrastructure or utilities by degree of urbanization, and so differences between rural and urban situations, a challenge for many SDGs as described in the Agenda 2030 for Sustainable Development. Okay, we saw some details of the population threshold from previous presentation, but how the degree of urbanization is computed. The degree of urbanization is basically composed by two main stages of settlement and administrative units classification, plus a preliminary stage to produce a population grid for a total of 3 steps. So from population data, census polygon, microcensus points, population grid in local projection, it is produced a population on a regular grid on which it is easy to apply simple general rules to identify and classify pixels into settlement typologies. The size of this grid cells was selected to be neither too big nor too small. If the square were too big, smaller settlements would be difficult to detect. Too small and single settlement may fragment in multiple pieces. As already mentioned, this method is meant to complement and not to replace existing national definitions. Let's start from the first step. The basis for this degree of urbanization is a square kilometer population grid in equal area projection. Each grid cell has the same shape and size, thereby avoiding distortion caused by using units varying in shape and size. And we already saw the advantages. The grid is produced from census data with 3 possible workflows according to the nature of census data: points, or more commonly polygons, in some case existing population grids. Points can be aggregated into pixels easily through rasterization procedure by adding pop counts. Polygons takes the population counts of the units and, using ancillary data as built-up surface, distribute the population within the unit pixels according to the ancillary density. Existing population grid could be reprojected using a volume-preserving working procedure developed by GHSL. On this grid, it is possible to apply the simple rules to define urban centers, urban clusters, and rural grid cells based on population size and density over length. I go quickly as this was already introduced by Lewis, and an urban center consists of contiguous grid cells using 4 connectivity, so not connected through the diagonal, with a density of at least 1,500 inhabitants per square kilometers. An urban center has a population of at least 50,000 people. Gaps smaller than 50 square kilometers in cluster are filled, and edges are smoothed using a majority filtering procedure. Urban clusters consist of contiguous grid cells using 8 connectivity with a density of at least 300 inhabitants per square kilometers, and has a population of at least 5,000 in the cluster. Given this, the urban centers are a subset of the corresponding urban cluster. Rural grid cells are cells that do not belong to an urban cluster. Most of these will have a density below 300 inhabitants per square kilometers. Some rural cells will have a higher density, but they are not part of a cluster with a sufficient population to be classified as an urban cluster. In a few countries, the degree of urbanization generates multiple urban centers for a single city. This occurs in countries with a relatively low density urban development and a strong separation of land and use function, such as Australia and US. Creating urban center using both cells with a density of at least 1,500 and cells that are at least 50% built up resolves this issue. Such highly built up cells typically contain office parks, shopping malls, factories, and transport infrastructure. In most countries, adding highly built up cells does not significantly affect the number of cities or their extent. Here is an example of Barranquilla urban center in the north of Colombia. We can see the red urban center surrounded by some urban clusters in orange, and all the green cells that are rural grid cells. The degree of urbanization presents also a more detailed characterization of settlement nested into the first level that goes beyond the urban-rural characterization to identify smaller settlements. Urban centers are defined as in level 1. Urban clusters are split into dense and semi-dense urban clusters according to their density, above 1,500 or below inhabitants per square kilometer, while all residual urban cluster peaks are not matching the size threshold classified as suburban or peri-urban areas. In rural areas, contiguous cells with higher density above 300 inhabitants per square kilometer with a total size of more than 500 people are identified as rural cluster, while all other peaks are classified according to their density above or below 50 inhabitants per square kilometer. Here, the color schema with rural pixels in shades of green, suburbs or peri-urban are yellow, and dense, semi-dense urban cluster in shade of brown, while urban centers are still red. And this was our Barranquilla example that at level 2 shows all small settlements popping up, dense and semi-dense urban cluster and rural clusters. So we have seen how to produce the population grid and the settlement grid. These are the two ingredients to classify any territorial units. Also for this step, there are two levels. The first level identifies units that are city, towns, suburbs, or rural area, according to the relative majority of people living in the administrative units. So given an administrative unit, all pixels that belong to this unit have a population value and a settlement classification. Population is summarized by settlement class, and classification follow very simple rules of majority, as we already saw. This procedure is performed at 50 meters, allowing the use of high-resolution population grid and avoid population displacement due to rasterization at 1 kilometer. To do so, the settlement grid is oversampled to 50 meters with all 50-meter pixels that inherit the classification of the bigger square kilometer pixel. The second level is again nested into the first, and the classification is assigned according to the majority of settlements within the level 1 classification. So if the unit is classified as rural area, I'll look into population living in rural clusters, low and very low density, identifying villages, rural dispersed areas, and mostly uninhabited areas. While if classification is town and suburbs, I need to look the population living in dense and semi-dense together, or suburbs, let's say against suburbs, and find the maximum between them. So if it is a town or a suburb, and if it is a town, I repeat the comparison between the dense and semi-dense towns to find the maximum between them and classify. This classification procedure makes possible to aggregate the local statistics per administrative unit by 3 or let's say 7 class, according if it's level 1 or we use the level 2. Okay, this was all theory. Well, in practice is even easier, as all this has been imported into a user-friendly environment. All these steps you have seen and that we apply to Colombia are produced using GHSL tools, freely available on our website, both as standalone tools or ArcGIS toolboxes. 3 main tools for the application of the degree of urbanization are the GHS population to grid, the GHS degree of urbanization grid, and finally the GHS degree of urbanization territorial unit classifier. In case of existing population grid in local projection, the GHS pop warp implements the volume preserving warping procedure to get the population grid in any projection and resolution from your already available grid. As said, all tools are freely available on our website for download, all documented, and we provide basic support for all users. Let's go more in detail to our case study of Colombia. Only 2 ingredients are needed: the 2018 population census, here as polygon with statistics, produced by the Departamento Administrativo Nacional de Estadística of Colombia. And as we saw, using census polygon, we need an auxiliary layer to disaggregate population data, the built-up layer GHS built S2, in this case, produced by GHSL for the epoch 2018. So the national population and housing census for Colombia was driven by 3 main objectives: to know how many people live in Colombia, where these people are located, and how they live. The production of periodic census is required by law, and the census constituted the main source of national statistics system. So this process was unfolded between 2013 and 2020, and include the many logistical and practical analysis phases. And there are several variables grouped in thematic areas: location, viviendas, so buildings, and households, and also people. So we have sex and age, education at all the administrative levels. These data are publicly available and were obtained through the Departamento Statistico of Colombia, the GeoPortal, and the 2018 census edition has been the first one that also facilitated by digitalization. So then we have the built-up. The GHS built S2 release 2020 is the first global product mapping built-up areas for the reference year 2018 using a convolutional neural network, the GHS S2 net. The layer builds on a new deep learning framework for pixel-wise large-scale classification of built-up areas, named GHS S2Net, to produce a global map of built-up areas expressed in terms of probability. This is a 10-meter spatial resolution and is derived from the Sentinel-2 global image composite. The main improvement of this layer compared to other remote sensing derived human settlement maps are the high balanced accuracy and the 2018 reference year. This layer has been pre-processed to transform the built-up presence probability to a built-up surface layer, more suitable for population disaggregation, through a binarization by thresholding probability at 0.2, then warped to mole wide at 50 meters by averaging values. So let's see now the results of all this process: the population grid, the settlement grid, classification of territorial units, and finally the statistics summarized by degree of urbanization. So we took the census polygon layer of Colombia, here shown as population density in Bogota area. It's quite detailed. It has a total of 550,000 units with about 47 million people. And we set this as main input of the GHS POP2G tool to generate population grid from census data. We set the pre-processed GHS S2 layer of built-up surface as ancillary layer, and we generate the population grid at 50 meters and then also at 1 square kilometer. The second output, sorry, I forgot this. Here you can say that looking at this grid, we have that half population lives in areas that have a density higher than 3,400 people per square kilometer, and less than 20% lives in pixel, 50-meter pixel with a density below 1,600 square kilometers. The second output of this GHS POP2G is the kilometric grid, here shown. That is basically the aggregation of the previous. And this, along with the built-up layer, is the ingredient, the input of the GHS DAG tool to create the settlement grid. We run the tool and we got the settlement grids. Here is the settlement grid in the area of Bogota. And we are able to calculate some statistics like the urban population, and so urban center and urban cluster population together. That is about 77.5%, with almost 57% of people living in urban center, and the rest equally split in urban cluster grid cells and rural grid cells. With the settlement grid, the GHS DAG identifies also settlement entities. That means a cluster of adjacent pixels that belong to the same classification, adjacent according to the 4 or 8 connectivity of the class. And for Colombia, it identifies 74 urban centers and 440 dense urban clusters. Here I report the list of the 10 most populated urban centers. I don't go into details, but you can have a look later if you are interested by downloading the presentation. That I think it should be shared if I'm not wrong. Then we used the settlement grid and the population grid produced at 50 meters as input for the GHS territorial unit classifier. And we produced a classification of all territorial units according to the degree of urbanization. In these results, we are able also to calculate the urban population by summing all population living in classes identified as cities or as towns and semi-dense areas. And the value is very similar to previous. It's about 78%, so share of urban population. Still, the majority is in the city units, 56%. Then, as the census provides also classification of urban areas, the scope called manzanas, and the rural, the sección rural, we can also compare the differences between national definition and degree of urbanization classification. And here we see how many nationally defined urban or rural are classified as cities, towns or rural. And we can see that we have a quite good match between the two, with 75% of what was defined, nationally defined as rural, that belongs to units classified, sorry, the population, 75% of rural population that belongs to units that are classified rural, and about 71% of the population that was in units classified as urban, that are cities. And then, as we already see in Deborah's presentation, we have something in between that are what is now classified as towns and semi-dense, that is 20% in of rural population and 20% of what was classified as urban. On the other way around, we could see how much population lives in units classified by degree of urbanization as cities, towns, and or rural. That was nationally defined urban or rural. The highest matches for population living in cities. More than 98% of this population is living in units already classified as urban. Still a good match also in the in rural, with 73% of population living in a rural area, classified rural areas that were already identified at national level as rural population. We also see that the intermediate classification identifies both urban and rural units, but the most of this population, 78%, is correctly classified in urban classes. But let's see now the analysis that we can produce with such classification of territorial units associated with statistics per unit. We can summarize these statistics by degree of urbanization, and we can start from population statistics, age structure, and gender distribution. Here you can see the age pyramids of Colombia by cities, towns, and rural areas. It should clearly appear that the peak of the distribution in different cities is different in cities. The class 20-29 years is different from the peak that we have in towns and rural, where the peak is in the class 10-19 years. And this basically shows that younger ages are dominant in the rural areas, and more than half of the population in these areas is 29 years old or younger. Moreover, cities host the majority of population groups in the ranges 20-29, 30-39, 40-49, and 50-59 years, and 60-69 years. These characteristics may relate to high access to opportunities offered by city, jobs, and education, as frequently reported in literature. The second characteristic that we can disaggregate is the gender distribution. As you can see from the graph, this has a clear split between urban and rural areas in Colombia. Male population is the majority in rural areas, 51.7%, and female is majority in urban domain, 52.1%, and highest in city, 52.5%, compared to a national proportion of 48.7% of males and 51.3% of females. In Colombia, well, we can also go to access to infrastructure and services, and from the census, we see that 96.3% of viviendas, so the buildings, are reported to have access to electricity. This statistics is related to the SDG 7, so affordable and clean energy. The degree of urbanization helps in disaggregating these national figures to identify the variation, and we have that urban areas have higher access. 99.5% of viviendas in cities are reported having access to electricity, compared to 97.6% in towns and semi-dense area, and only 86.3% in rural areas, that is 10% less than compared to the national average. In particular, mostly uninhabited areas report the lowest national share of viviendas with access to electricity, 58.7%. Access to internet is a growing need to exploit opportunities brought by digitalization. Also in the SDG context, there are specific goals on this. We have SDG 9 and SDG 17. In the census of Colombia, we have the number of viviendas with access to internet. That is 41.5 at national level. And we have 60% of the viviendas in cities with access to internet, while this dropped to 1.8 in mostly uninhabited areas, 7% in villages. This is a clear digital divide between cities and the rest of settlements.
Marcello,
I'm going to close my presentation with some few things. We have also the distribution for the access to water according to the degree of urbanization. Here we have same trend from lowest access to mostly uninhabited areas to highest in cities. Less than 20% in most uninhabited areas have access to water, while more than 80% access this service in cities. We have other data on the sewage system access, SDG 6, same pattern as before, with villages that are the most connected in the rural domain, almost 40%, and cities are still dominant with more, let's say, mostly connected to sewage system. And finally, something about SDG 11. We have the waste management, access to waste management service. The pattern is a bit less linear, but still low access in mostly uninhabited areas, about 6%, and villages that stand out with 46%. But we have suburban and peri-urban areas that have more access to this service than semi-dense towns. This can be probably due to that the service can be managed easily in the main core town or urban centers. The suburbs of peri-urban areas is linked, while semi-dense towns are by construction isolated towns. So to conclude, we used our GHSL tools with only 2 inputs to disaggregate the census and produce population grid and settlement grid classification easily with using the GHSL users. And we also disaggregate statistics by degree of urbanization. We got quite close match between classification of local units based on the national definition and the degree of urbanization. And we saw this gradient between urban and rural access across the variables. Well, you can say that this statistic could have been summarized using the national definition without all this process. That's true, but I see at least 2 main advantages. First, the classification is much more detailed, as from 2 urban rural classes, we go to 7 classes. And second, and maybe, let's say, more important, these results are finally comparable with same results from other countries, making possible international comparison of statistics, as all is based on a common definition. So with this I conclude. Thank you for your attention, and sorry to be going using.
No worries, no worries. Thanks very much, Marcello. It's very, very interesting talk. So, you know, I thank you to all of our speakers as well. You know, as you mentioned, Marcello, these presentations will be available for download on the GFGS wiki page. So I'm putting that link in the chat for everyone. This was the 3rd in a series of coffee talks, and we're planning more over the next several months. So please visit the wiki and, you know, reach out to us if you have any comments or recommendations for topics, or if you're interested in speaking at one of these about a specific topic. It would be great to hear from you. So, you know, monitoring the chat, I see that there's a very robust conversation going on there about urban definitions, and I think that this is exactly what we're looking for in this global forum, is to facilitate these types of exchanges. So Stephen has put the questions up on the screen. You know, I know that some of them have been answered already. So for the ones that have not been answered, I think I'd like to start off with Deborah. So Deborah, there are 2 questions here from Hannes and Inkyung. So Hannes asks, finer detailed input data, they may hide clear relationships when we see larger aggregation levels, or the noise issue. Which resolution, in your opinion, is most appropriate according to your experience?
So thanks for the question. And I did try to answer one of the questions in the chat, but it went like in a private message rather than to the group. So I'll repeat that for everybody. I'm happy to have it posted for the group. But this other question I missed on the finer input data, I'm not actually suggesting that they one of the reasons for having the finest units is so they can be reorganized and aggregated. So I'm not, there will be times when the finest resolution data are, are in some ways have some are problematic. I'm not, or there's precision issues associated with them, depending upon. But I also, in answering in the second question, the minimum fine resolution data that every country should be able to supply is population by age, sex, and whatever urban definition the country itself uses. Those are in the sort of, usually all countries have some urban definition. Those criteria differ by countries, as we know, like why, vastly, there are vast differences, but every small aerial unit pretty much has some designation. So that designation, along with the population by age and sex, would be at a minimum, and there would be no privacy concerns associated with that. That is easy. That is, and I don't actually think that in and of itself, with the exception of places where the boundary data might be in question, I don't see that as having as being problematic in terms of being overly precise. The model's going to come around and make these more precise anyway, right? Somebody's going to model them into an even more like the population modeling community will add precision. This will aid in that precision. And having these small aerial units allows for mixing and matching and thinking about them, like which of these areas might be connected. The whole conversation, which I haven't had, which I think is really good on the on contiguity rules and what's in the middle. All those things would be aided by these kind of data. These kind of data will help us. I mean, to that point, though, the things that can be added on, like if it's known whether something is in a given commuting zone, if it's known, like the education of those small aerial units, where those are available, those can add a lot. But I think that there's quite a bit of variation across countries in how that's done, so I wouldn't expect that's a very high bar. But the other bar, age, sex, and urban definition, not a high bar. And therefore, everybody should meet that one. And then a few countries should go out and set an example, add commuting zones, because commuting zones are very often a part of that urban definition. So that would be great. And that would then help think about some of these other thornier issues about what are these peri-urban areas? What are these connected areas? What is the right method or concept for putting these together? Do we want to use hexagons or some other contiguity rule? That's all I'll say.
Sure, thanks a lot. So I think that you also got at Inkyung's question there, which is, what other things would you want to see in the data product and what could be easy to make researchers use this kind of high resolution data? I do want to mention that we're coming to the top of the hour here, but we are going to keep the connection open for anyone who's able to stay on and wants to continue discussing this for a few more minutes. So just a couple of technical things. Vilni had asked, does JRC plan on making DEGURBA method available and open source? And I think Marcello in his presentation, he showed some examples of the tools that are available that, are freely available for people to use. With the issue on hexagon grids, Thomas, we should follow up offline about this, as Kevin Saar on our steering committee of the GFGS is an expert in hexagon models, and he's willing to work together on some of these things where resources might be an issue for organizations. So I'll follow up with you independently on that. Marcello, a question from Nick is, a technical question. It says inhabited and rural areas are regionally differently assigned. So how were the threshold values of 300 and 1,500 inhabitants selected?
Well, I think this is more a question for Louis.
I'm happy to answer that.
I know we ran let's say, a sensitivity analysis on this. Based on the result of this analysis, those thresholds were selected. Maybe Louis, you can add some.
Yeah, so they were first developed when we had a European grid. We had Geostat 2006 and then Geostat 2011. And basically, we've tested a whole range of density and size thresholds and compared those results both to national definitions and to settlement definitions, right? And the goal was to try and find some threshold of size and density that captured individual settlements. And then once we had a global grid, we could do the same, But obviously, the quality of countries, as Deborah highlighted, when the population data has very coarse resolution, it's very difficult to really estimate it at a fine scale to really capture all the variations in density. But we found in countries as different as Australia and Brazil that once you map these settlements, typically you find a little nucleus of a settlement, and typically it has a name. So this kind of gave us a lot of confidence that yes, we are capturing a settlement structure that's already recognized and named in those countries. So that was another reason why we kept the ones. But I want to be fully transparent. When we started this process in 2016, I went in fully expecting to have to change the density thresholds. I thought, no way this is going to work globally. But country after country, and really different countries, you know, South Africa versus Korea, they said, no, Lewis, this is fine. This works really well. I'm like, really? So yeah, we actually consulted 100 countries on this definition to get their feedback. And I think most of them said, no, this really does a good job of capturing our settlements. So if they're
Sure.
happy, I'm happy.
Sure, that's great. I think there were a couple questions about this, but you know, as you say, if the community supports the definition, that's really a driving force in accepting a definition. So Marcello, another technical question from Roberto is there a defined standard size of cells recommended for supporting generating SDG indicators? So we may have lost Marcello.
Yeah, maybe he has also some family related issues. He texted me. I can come in here. So the SDG reporting is there's no spatial unit defined. For the degree of urbanization, we focus at 1 kilometric grid cell. But for other SDGs indicators and other data, you may also use different resolutions, and you don't have to resort to the grid. So you may also report on the land use efficiency, not at the grid level, but at the administrative unit level.
Sure. Thank you, Thomas. There's also a comment from Naeem that is very useful and interesting, and they would like to try the model for a use case in Tunisia. And, you know, I don't think I'm speaking out of turn to say that you would be open to further contact with them if they want to try to implement this model.
Yes, definitely. I put already there the link to our tools, and there was also the link in Marcello's presentation for all the documentation, the manual from Eurostat as a good starter for reading, and then get back to us if you have additional questions.
Sure, that sounds good. So, you know, the questions that are left are these deep questions about the DEGURBA methodology that I think it is important to discuss, although given our time constraints, I'm not sure if this is the right forum for that. But Lewis, you know, I'll leave it up to you how far you want to get into responding to this, and go ahead.
Thank you, Kit. Yeah, I mean, this is not a discussion that's going to end here, or what I'm going to say is hardly going to be conclusive. So let me try and pick up a few points, right? Solly asked about the 300 inhabitants. Hannes also asked about the 300 inhabitants. And basically, it was empirically derived from applying it to the population grid and looking at the results and comparing it to national definitions and national settlements. So it was really empirically driven, and the consultation was designed exactly to see whether this this needed to change. I think the big misunderstanding is that people focus on the density threshold, right? But it's only one threshold. And actually the sensitivity analysis shows that changing that density threshold doesn't change that much. It's really the size threshold that really determines the changes. And so whether you move from 300 to 400 or to 200 or 600, it's not going to change that much because population density, there's big jumps in it. And settlements typically are quite dense. So even some of the villages and towns we identify have a density of 5,000 inhabitants per square kilometer. So I don't focalize too much on the 300. It's really the size thresholds that drive the results in most countries. Then the second thing, I would say is about suburbs, urban, rural, different perceptions of areas in different countries, right? So I've already highlighted that for a lot of countries, it was really difficult to accept that we proposed a definition of urban and rural that didn't include certain services. They were like, but you know, you have to include access to electricity. You have to include access to water. That's what we do. And I kept trying to say, yes, but we want to know if there is water there. And if you want to know if it's there, it can't be part of your definition. FAO made this brilliant point. You know, you can't monitor rural poverty if your definition of a rural area is a poor area, right? It's circular. You can't do that. And so people still really struggle with that. But I really think it's just a different way of looking at things. Urban is not a status. It's not a flag of having achieved a certain level of development or a certain economic structure. It's merely a settlement of a certain size and density. That's all it is. And then once we have identified, we check to see, do they have Wi-Fi? Do they have a mobile phone? So it's looking at it from a different angle, but it's hard to get it people's head to look at it from a different angle sometimes. Last thing I would say, we clearly made the decision not to link it to agriculture, right? If you want to define agricultural regions, that's fine, but that's something else. Employment and agriculture vary so much between countries and over time that it's not good to build a stable, durable definition that allows you to do comparisons across countries and over time. So I really didn't want to include that. So yes, we will have rural areas where almost nobody works in agriculture. Probably most of the rural areas in the US, nobody works in agriculture, or almost nobody. I mean, the numbers are so small. And yes, we will have towns and suburbs or towns and semi-dense area where a large share of the population works in agriculture. That's not a bug, that's a feature. That was our goal because these settlements still have the size and the density to make it cheaper and simpler to provide services like a hospital, like a school, like a Wi-Fi, like mobile phone coverage, etc. Now, I could go on for a long time, but I'll stop there. So,
no, thank you so much. You know, I think that the robustness of this conversation and the fact that so many people have stayed on over the hour, it shows that just how important this work is. And, you know, we want to applaud you and thank all of our presenters today for doing this very important work and for, you know, providing it to the community to keep on pushing the ball farther. So, you know, just to close, I mentioned before that this global forum on geography and statistics, we have been holding these monthly coffee talks, and we will continue to. Stephen has put some links in the chat that will be useful if you want to follow along with that. And he's also mentioned that we do have some openings on our steering committee. And if you're interested in engaging in these types of discussions, we'd really be ecstatic to hear from you. So please follow up through those links below. And thanks everyone for taking the time to be with us today. And thanks again for all of our speakers. It's very much appreciated. So with that, have a great week.
Thank you, Kit.
thanks, Kit. And to the other people, happy to continue the conversation offline. You just email me.